So without further ado, I'm going to pass over to Antonio. And Antonio, you are our, let me just double check, you are our 15th session of 24. So welcome.
Hello, ladies and gentlemen. So I'm going to switch to my slides. I'll be doing this session, this talk, which will be slides and code and command line. So I'm going to talk about something very old, app servers. I'm sure you've heard about them. They are nearly 20 years old, and I have a few things to say about them. First of all, I'm Antonio Goncalves. I'm a developer. I'm a contractor here in Paris, France. I've written many books about Java EE. So I have a book about Java EE 5, 6, and 7. I've created the Paris Java user group, so I like jugs, even if they have virtual, love it. And plenty of other things, and I'm even a Java champion. So this is me. This is me, and I'm going to talk to you about application servers. I have this catchphrase, which is take what you need from Java EE and resize your app server, because Java EE is a history of fat servers. So I want to tell you a few things about them. We are in 2016. Things have changed a bit. How do we see application servers? How do we see Java EE application servers? Well, we see them as a one block, a monolith, one big application server. It's so big that it's slow, fat, boring, heavyweight. When we talk about Java EE, a lot of people say that it's heavyweight. Old, it's nearly 20 years old. Java EE, the first version of Java EE was in 1998. So it's nearly 20 years now. And because it's old, guess what? It's not sexy. So let's take them one by one. Okay, so application servers are monolithic. That's what we hear. This is how we see Java EE application server, one big block. In terms of implementation, when we talk about Java EE, we think of Oracle WebLogic, Glassfish and Payara, WebSphere, Wildfly, and JBoss. So these are the application server that implement Java EE. But from Java EE 6 onwards, we created the web profile, which is a subset of Java EE. So as you can see, the rectangle is slightly smaller. So when you implement Java EE, like WebLogic, JBoss, Payara, and WebSphere, you must implement the web profile. But on this web profile thing, we have other players that only do implement the web profile. Apache Tommy, Caucho, COPAS. And we also know the servlet containers. These are the Jetty, the Tomcat, and the Undertow that we've been using for many, many years. So application servers are full Java EE application servers, web profile, which is a subset, and servlet containers. So they are not one big block. They are three big blocks. Not really, because actually, by design, application servers are just a jigsaw puzzle with bits and pieces. If we look at the servlet containers, Tomcat, Jetty, and Undertow, they all implement these four specifications, mostly servlet, expression language, JSTL, and JSP. So by design, the servlet containers are actually implementing 4 bits. Then the web profile This comes on top of servlets and adds things like CDI, JPA, WebSocket, JAX-RS, and JSON-P. So that's what implements Tommy or Caucho. And then we have the full Java EE. So when we talk about full Java EE containers, it implements Java EE 7, implements 34 specifications. So there are most of them. So as you can see, by design, Java EE is a jigsaw puzzle. The CDI specification evolves on its own. The JTA specification evolves on its own. They have different life cycle, different release number, and once in a while they gather all together under the umbrella Java EE 7, Java EE 6. So it's just bits and pieces, and of course it runs on the JVM. And once we have all these bits and pieces, what we do is we write some code. So this, the red bit, it's the business code that we actually create.
Antonio, sorry, I hate to interrupt you. When you're in your flow, should there be? Should you be sharing your screen?
Sorry?
Should you be sharing your screen? Are you talking over slides?
Yes, I am.
Ah, okay. You're not sharing your screen.
Oh, sorry.
It's okay because you were talking in such an animated way. It was actually very, very natural. So.
Oh, and what about now?
But that's perfect.
Oh, okay. So let me go very quickly. Sorry about that, guys. So I was saying that Java EE is a big block, but there's a web profile, and actually there's the servlet containers, and that's even smaller because you know, it's just bits and pieces. So I had this fantastic animation that you missed, and I was saying that all these bits and pieces run on the JVM, which hopefully one day will also be bits and pieces. And I was saying that when we use a Java EE application server, that's what we get. And we write some business code. So this in red, it's the code that we produce that runs on top of this huge amount of bits and pieces. And then we ask our friends Maven or Gradle to bring the missing bits. So if you do Java EE, that's what you've been doing for the 20 last years. We write some code, ask Maven to bring all the dependencies, package that in a WAR file, and run on top of all these little bits. But as you can see, application servers by design are not monolithic. Okay, they're just an aggregation of bits that are different life cycles. Application servers are slow. That's also what we hear. So this is a graph. I'm going to explain that. You know, here in France, sometimes winter is long and cold. So I stay at home, I download all the application servers. So here at the bottom, you can see all the application servers. On the right side, you have all the servlet containers, Tomcat, 8.9, Jetty, and Undertow. Then in the middle, in gray, you have the web profile. So the application server that only do implement the web profile. That's where we find Resin, Tommy, and also Glassfish Web and Payara Web. And then on the left side, you have all the blue. So the blue is the full Java EE application servers. So here I've downloaded all the application servers and I started them completely empty. So think of it, you download JBoss completely empty. It's a zip file. You unzip it, start it, start, stop, start, stop. So you warm up some temporary cache and stuff like that. And here are the startup time in milliseconds, completely empty. You know, I will talk about that later. But what's interesting to see is a servlet container that only implements 4 specifications, like Tomcat, starts up in half a second. But what's interesting is to see that Wildfly 10, which is a full Java EE application server, implements the 34 specifications of Java EE. So just to see that application servers, it depends of what you mean behind slow. Of course, unfortunately, WebLogic 12 takes a lot of time compared to the others, nearly 10 seconds to start up. But if you see the extremes, the servlet containers from Tomcat to Wildfly, it's only 4 times slower. So one starts up in half a second, the other one starts up in 2 seconds with full Java EE. This is another graph. So what I've done, that was a bit more tricky, because as you can see at the bottom, I managed to find a JBoss 3.2, very, very long time. It implements J2EE 1.3. And then I found a JBoss 4, JBoss 5, 6, and 7. I had to run on VirtualBox, on a Windows box, because, JBoss 3 is very, very old. So I did the same thing. So here, the yellow line shows the number of specifications implemented by the application server. J2EE 1.3 was only 12 specifications, and Java EE 7, it's 34 specifications. So here, the yellow line is just saying that application servers do more and more. And here, the red line is the startup time. So again, think about it. I just go online, download the application server, empty, and I go start, stop, start, stop. And you can see that JBoss 7 starts quicker than JBoss 3. And yet it does 3 times more. It implements 3 times more specifications. So also just to tell you that things have changed. Technology, was evolved. Now we are running Java 8 with garbage collector and so on. So it's not because you implement more specifications that it's slower. Okay. So application servers are slow? No, they are not. So now we can say, well, application servers consume resources, and they consume a lot of memory. I did the same thing. I've downloaded all the application servers, start, stop, start, stop. And this time I check the JVM, the heap of the JVM. And I start up an application server. I took the maximum memory and I did some GC and took the lower band and waited for the application server to settle down in terms of memory footprint. Again, if you look at the extreme right, you can see that Tomcat takes roughly 50 megs of RAM, and Wildfly takes 100 megs of RAM. Okay, Tomcat for specifications, 50 megs, Wildfly 34 specifications, 100 megs. Yeah, WebSphere in the middle, WebLogic, those guys are still a bit, fatter than the others. Okay, so application server do not consume a lot of memory. They are not slow. They are not a monolith. But I want to talk to you about something. They use outdated packaging. That's why I hear a lot. So, what can we do in terms of packaging? This is our jigsaw puzzle, okay? The JVM at the bottom, Java EE, full Java EE in the middle, and at the top, our code, our business code, and our dependencies. No matter what we use, no matter what is our business code and our dependencies, we rely on full Java EE. So we use all these bits and pieces, even if our business code does not use them. If you start a full Java EE application servers, you have EJBs, if you like them or not, if you use them or not. So that's what we do. And in Java EE, what we tend to do is we take all our code and our dependencies, package them in a WAR file. We call that a skinny WAR because there's just our code and our dependencies. Why? Because we rely on a full Java EE application server at the bottom. So when you come from Java EE world, we talk about skinny WAR. Our WARs are thin. If you come from a Spring world, we talk about fat WARs because Spring usually runs on a servlet container, so the bits at the bottom, servlets. And then if you need JPA, you must add Hibernate. If you need JAX-RS, you must add Jersey or REST Easy. So in Java EE, we have a skinny WAR because we only have our business code and dependencies. When we come from a Spring world, we have fat WARs because we have to bundle all the dependencies, including the Java EE dependencies, in our WAR file and deploy it on a servlet container. So that's what we've been doing. So that's what I'm going to show you. I'm going to show you a demo of a web application server, a CD and bookstore. Very, very basic, but I will explain you how its structure, its architecture, and why all this matters. So let me turn back to the CD bookstore. So as you can see, this is a website. Here you have the 5 top rated books, and here at the bottom you have the top rated CDs, and you can connect. So I'm going to connect as an administrator. If I log in as an administrator, I have this tab here, admin, and then I can, I can do CRUD operations on CDs. So here I can edit a CD. I can change, the price and so on. Can change the genre, music label and so on, category. I can create a new one. I can click, so when I'm an admin, I have all these CRUD, operations that I can do. And you see it's a full web app, so I can check the profile, I can log out. And when I log in as a user this time, I can actually buy a book. Okay, so here I have all the details of a book, the ranking, and when I go buy, I have a shopping cart here. So I can look, Java, books by title, and I can buy a second book. Okay, and I go back to the shopping cart and check out. So it sends an email, etc., etc., etc. Okay, why am I showing you that? Because here it's a full Java EE application. I will show you a bit of code, but there's JSF, EJBs, security, and so on. But here, to show the top rated books, I actually use an external, let's say, microservice. So here I have top books. So it's another application. It returns some JSON, which is, the ISBN number of a book. So the 5, each time I refresh, it's new books because it's kind of a random, but these web service, this microservice, top books, returns a list of 5 books, and that's the one I show here. And again, for the CDs, that's a different microservice that only returns an ID of a CD. All these 3 applications are deployed in a single Wildfly. So, if I undeploy top CD, gone. And if I go back to the CD bookstore, the tab with the top rated CDs is gone. Okay, this application cannot communicate to the microservice. And let's do the same thing for the top books, just so you understand this connection. So top book is gone. Now the home page of the CD bookstore is empty. Okay, so CD bookstore, full web application. And I will show you a bit of code. Top books, a bit of JPA because there's a database, and top CD, there's nothing much. And that's the one I will show you for a few examples. Okay, so now I just undeploy CD bookstores. Okay, everything is gone, and I'm gonna actually stop Wildfly. Okay, come back quickly to my slides. So I've done a demo of these three applications: a full web app and 2 microservices. These 3 applications have 3 different needs. I'm talking about technical needs. The CD bookstore uses most of Java EE. So here I've highlighted the bits and pieces that I use and blurred the ones that I don't. So CD bookstore doesn't use JMS, but it uses JSF, EJB, JAX-RS, CDI, and JPA, and so on. Okay. Top books, that I use a database. So I'm using JPA and JTA because all the top rated books are in a database. The interesting bit is top CDs. I've created only one servlet, so I'm not even using JAX-RS. I'm using only one servlet that returns a JSON string of the top rated CDs. So as you can see here, the top CD only needs 1 bit in pieces, only one piece, the servlet API. That's all. But yet, I have to run it on a full Java EE application server. What a waste, isn't it? What about packaging only what we need in a fat jar? Why not take all the bits, the Java EE bits, as a dependency and put them in a fat jar? Wouldn't it be nicer if for the CD bookstore, I would say, I do not need JMS. I'm going to only package EJB and JSF and JPA in a fat jar running on a JVM. Same for top books. As you can see, it's even smaller. There's no EJBs, there's no JSF. And wouldn't it be that perfect for top CDs? Top CD is just one servlet. Actually, this fat jar approach already works on Java EE. I'm going to use FlySwamp, but the same mechanism exists in Payara Micro, Tommy, WebSphere, and there's even another framework called Cumuluzi. So that's the full Java EE solutions. And you also have Spring Boot that also brought this idea of fat jars. They do sort of Java EE. They implement some specifications of Java EE, but not all of them. And then you have other things like Drop Wizard or Legume. I'm going to use FlySwamp, okay? And I'm going to show you what can be done today in terms of packaging. So this time I'm going to switch to my command line. Here, as I said, it's 3 applications: CD bookstore, top books, top CD. If I go on top CDs and I do a LL on target because it's a Maven project, I can see that the WAV file is 5Ks. Yes, because if I show you some code, So here is my top CD. And if you look at top CD, it's only one servlet. There's not even a web XML file. I'm using a web servlet. And what I do is I create some JSON by hand. And, as you can see, the top 5 CDs, it's only random numbers. So only one class. And if you package it in a WAR file, it's 5Ks. It's just this class. That's the skinny WAR approach. While FlySwamp can help me. Here I have a Maven profile, and I'm saying if you build your WAR file using the Swarm plugin, what I'm going to do is I'm going to add these fractions. So FlySwamp has this idea of a fraction. A fraction can be one specification or one technology. Undertow is a servlet container. So here I'm saying top CD, it's only one servlet. It only needs undertow. That's all. And I'm saying, well, if I build this servlet under the profile Swarm, I'm asking Swarm to create a fat jar with my code and with a fraction undertow. Okay? And here I'm saying it will listen on port 8081. So let's do that. I'm saying Maven clean install, and here I'm using the profile Swarm. Maven will ask the FlySwamp plugin to do its job, and what's going to happen is FlySwamp will package my code undertow under a fat jar. Okay, so I went from a 5K WAR to a 32 megs fat jar. Java.jar cd swarm. Okay, and this will run just what I need. Undertow with my servlet. And I can show you it's working, because if I go on port 8081, working. Okay. Now, top books. Top books is a bit more complex. There's JAX-RS. So here, to get the list of the top books, I actually use a JAX-RS endpoint. I use JPA to get a query, etc., etc. If I look at the POM XML and at the Swarm profile, I'm saying top books needs undertow because it needs a servlet container, JAX-RS, CDI, and JPA. And it's going to listen on port 8082. So if I go to top books, LL target, I have a 9K, not even 10K WAR file. And as you understood, if I build it with the Swarm profile, I will go from 10Ks to more than that, because it needs to bundle my code plus JPA plus bin validation, etc., etc. And I have 100 megabyte. Let's do that again. Java jar target top books Swarm. It's going to start up again only what's needed. I can even show you the logs, because when you start it, it tells you, oh, here, if I decrease slightly, it's telling me that it needs the fraction container, logging, bin validation, and so on. That's why it's 100 megabytes. And as you can guess, I'm not going to show you all the code, but let me show you something. See, I have JTA here, I have transactions. I even have EJBs. Oh my God. I have a JSF pages. I have both, authentication and so on. So CD Bookstore, because it also has prime faces, the WAV file is 5 megabytes. So it's my code plus jQuery plus, all these things. And as you can guess, if I package it with the SWAM, so let's have a look at the POM XML. Here I'm saying if you build it with SWAM, you need the undertow fraction, JAX-RS, CDI, JPA, EJB, JSF, nearly the full Monty. And here I went from a 5 megabytes to 114. And as you can guess, I'll just go CD Bookstore, SWAM. Here it goes. Takes slightly longer because there's more things, there's more code, more dependencies, and more fractions. Now, I didn't show you, but books is running on port 8082, and CD Bookstore is running. And on the web page, on the main page, I can see the top rated books and top rated CDs because it talks to my services. And if I kill them, then my 2 microservices are gone. The home page is empty. Okay. So here I've showed you that with frameworks like FlySwamp, Payara, and so on, we can now in Java EE have this fat jar approach. We take the bits and pieces of Java EE and bundle them into a jar with our code. What about multiple apps? That's quite interesting of our world of microservices. The top CD, I have one, but the idea is to have as many as I need to scale. They are so tiny that they, I can run hundreds, thousands of them. Have a look at that. With FlySwamp, we package our code with the servlet fraction. Here it's undertow. Don't you think that this servlet fraction happens all the time? Wouldn't it be better if we take it out and leave it where it is in the Maven repo and just point at it? That's another way of packaging. We went from skinny wars to fat jars, and what about that? What about just have our business code pointing at our dependencies on our Maven repo? FlySwamp can do that. How? Here I have, sorry. I'm going to show you top CD now because it's, it's the smallest one and it's quite interesting. So you've seen the Swarm profile. Now I have this one, Swarm2 repo. It's exactly the same because it needs one fraction. Remember that this is the servlet and it only needs a servlet container. And the only difference between the Swarm and Swarm repo is here I said bundle dependencies equals false. What does it mean? It means that if I go back to top CDs, as you can see, the fat jar is 32 megabytes. But if I package it with M2 repo, I'm telling Swarm, do not put undertow in my fat jar, leave it on Maven. So I went from a 32 megs to a 700 Ks. And look, if I start it, I can see this log here. Dependencies not bundle will resolve from local M2 repo. So as you can see, that it's another way of packaging. I hadn't thought about that before FlySwamp. So I was talking about multiple apps. Some metrics, okay? Here, this in blue, it's Wildfly zipped. So if you go online, download Wildfly, it's 140K megs zipped, okay? So the entire Wildfly is 140 megs zipped. The CD bookstore, so the full Monty, if I have a skinny war approach, it's only 5 megs, but it takes nearly all Wildfly, because here I use most of the Java EE specifications. So our FAT jar is 120 something megabytes. And if we go to the right, the top CDs, the skinny war is very skinny. It was only 5Ks. And the FAT jar is 30 something megabytes, 32 megs. So just to give you that this idea of this is Wildfly full, and if you use most of Java EE, you can see that you don't gain a lot in size. But to the extreme, if you look at top CDs, instead of 140 megs, it only uses 30 megs because I only need the servlet container fraction. So that was just some numbers. Startup time. Again, here at the bottom in blue, that's Wildfly. I download Wildfly, start, stop, start, stop. Wildfly starts in 2 seconds, empty. Here at the top, I have the top CD. So only one servlet with the undertow fraction. FAT jar, if I start it up, the container plus the application is 1 second. And as you can see, it's less than only Wildfly alone. And here, the second row, the top CD Wildfly, is the skinny war approach. So as you can see here, Wildfly empty takes 2 seconds to start up. With our top CD, it takes 2.5 seconds to start up. But with our FAT jar approach, it only takes 1 second. So yes, the FAT jar is faster at startup because it only needs the needed fractions. Wildfly here takes a lot of time to boot things up that we don't even need. And same thing, it's always the same pattern. The FAT jar is always faster than the skinny war because there's less fractions to start up. So that was just to give you more information, more metrics about startup time. Okay, so we come from a history of we start up an application server, we go to the admin console, we set up the data source, we connect to the database, we create our connections, our JMS factories, and so on, and then we deploy our WAR file. How do I manage it now if everything is in a FAT jar? So that's the missing bit. We need an API, a Java API, to configure a Java EE application server. This is not specified yet. Everybody does its own way, and this is the way FlySwamp does. We can, in our code, in our business code, have a main class and configure our application server. So here we're saying, I'm going to create a new container. So that's the Wildfly container. And at the end of the day, I'm going to start it and deploy the code. And between these lines, I can create a JDBC driver. I can configure a JDBC driver and a data source. So if I do that, I package this main class with my business code, with the fractions under a FAT jar. And now, when you start up FlySwamp, when you start up your FAT jar, it creates it configures a driver and a data source. So that's one way of doing. So it's still Java code inside our FAT jar. This code can point at properties in an external file. But there's also something more that we can do with FlySwamp, and I'm going to show you. I'm going to do a demo with FlySwamp in management. So here I have, here I have, again, I stick to top CD because it's the smallest one. I have another profile. And here I'm saying, well, our business code, our servlet, needs undertow, okay? But now I want to add the management fraction. And what's that? It's nothing more, nothing less than the management API of Wildfly, of JBoss. So if I package my servlet with this profile, FlySwamp is going to package, the undertow and the management. So if I, again, execute it, I'm going to see here at startup that the container start the login, the naming, undertow, and the management fraction. So now it's up and running. Okay, I can still go to my top CDs. See, I can see my CDs. But now that I have this management fraction, I can go back to my good old JBoss CLI. I don't know if you're aware of, for people who use JBoss in production, I'm sure you're aware of JBoss CLI. It's a way to ask information to our container using command lines. So here I connect to my FlySwamp, and as you can see, it's connected. And now I can ask questions like deployment info. And look how interesting that is. It's saying that I have the top CD WAR that is deployed in our jar. Isn't that funny? So there's a WAR deployed inside a jar. And I can ask, other, give me all the informations of undertow subsystem. And from here, I can create a data source. I can create a GMS factory and so on. Coming back to the deployment info, I still, I want to show you something. So this is my top CD. My FAT jar is 33 megs. And if I unzip, if I unzip this top CD FAT jar, what's inside this structure? If I do a tree, so here I'm going to go full screen, going up a little bit to show you what's inside this FAT jar. Oops. Well, there's some meta information. There's unfortunately, some hacks for all the XML factories and so on. But look, inside our jar file, there's our WAR file, our skinny WAR file, our 5Ks WAR file. And here I have the M2 repo directory with all the needed jar files. Okay, so that's our FlySwamp. It takes all the dependencies, put them into structure, the Maven repo structure, and puts our untouched WAR file inside our jar. Okay. Yes, and what about Docker? I can say plenty of things about Docker, but I'm going to be quick. Well, it's just Java now. So the Docker file can be as simple as that. I just need Java. I'm going to expose a port. We're talking about top CDs. I'm exposing port 8081. And I'm adding the top CD Swarm, so the fat jar, in my Docker, and doing a java.jar. And that's all. So, as you can see, my Docker file is only a few lines. So I can show you the demo on Docker. I first need to start up Docker. And if you look at my Docker file, it's exactly what I've shown you. So I just need Java 8. I do not need Wildfly. I do not need, anything. It's a standalone FAT jar that I have. So only Java 8 is needed. And now I can go Docker Compose up. And that's it. Okay, so I just need Java 8, and it's still up and running. So I won't tell you more about Docker. I just wanted to show you that. But skinny wars are much better when we live in the Docker world, because it's faster to build. It's much faster to build a 5K WAR file than a 32 megabytes fat jars. So skinny wars are actually much better when we live in the Docker world, in terms of, it's faster. Faster to build. The Docker image is faster to build. So that was my demo. I even have a Raspberry Pi demo, but I can't show you it here. But I promise it's true. I have a Raspberry Pi 2, and I can run the 3 services just with a Java jar, running EJBs and so on, the full Monty. So all the demos I've done, I can do them on a Raspberry Pi, but here it's a bit difficult to show. Sorry about that. Final world. What I like about FlySwamp and the others too, Tommy and Payara. But what I like about FlySwamp is I have a good knowledge of JBoss, and the command line is the same, the logs are the same, the structure is the same. So when you come from JBoss, FlySwamp is very easy. Then it bundles several fractions. And again, I'm a Java EE expert, so I'm more than happy to use my expertise in this new world of microservices. So FlySwamp comes with all the Java EE fractions, but it also has other fractions: Spring, Logstash, Swagger, Netflix, plenty of fractions. So you can easily bundle Swagger in your microservices with FlySwamp. So, final world Java EE application servers have changed. They're 20 years old. They have evolved to funny, interesting beasts. They are not monolithic by design. I don't know how that happened, but it's not. It's a bunch of specifications that evolved at their own pace. They are not slow anymore. They do not consume resources. They can even run on Raspberry Pis. And now, we can package how we want, really. We have skinny wars and fat wars and Uber jars. It just depends on what you need. The interesting thing is I didn't touch my code. So it's the same servlet that runs on Wildfly or FlySwamp. So I do not have to change my code. I can reuse my Java EE expertise, and I can go, yes, look, I'm doing microservices, woohoo. Or if you do not make microservices and you do a monolith, a centralized monolith, and you are proud of it, good. If it works, fine, stick with it. That's it, guys and girls. So buy my book if you haven't done so. Watch my talks on plural sites if you haven't done so. And thank you. If you have any questions, I think I have a few minutes.
Awesome. Thank you very, very much, Antonio. A couple of questions then. Let me
And sorry for the lack of slides at the beginning.
Oh, don't mention it. So, question from Kiko, K-I-K-O. Hey, Antonio, I have a question. Do you think glassfish can still be used in a production environment? Presumably referring to the lack of support from, or the dropped support from Oracle.
No, go to Payara. Payara is a fork of Glassfish. It's supported by a company and it has support. You know, two years ago, everybody was playing hide and seek. Now let's be straight. Let's be a man and say, forget Glassfish, unfortunately.
Okay. Another question from me, actually. What's your opinion on serverless technologies?
I think we're just scratching our head to try to understand what microservice means. I'm not sure I've understood what serverless means. I read about it, but I've stopped scratching my head on microservices. Now I'm starting scratching my head on serverless. I I do not see how it works in my world. So unfortunately, I can't give you more information on that.
Okay. And the final question, you're gonna need to unshare your screen actually for this final question.
What? Sorry?
You're still sharing your screen actually, so you're gonna need to unshare your screen.
Oh, is it okay now?
There we go. Perfect.
Okay.
Okay, so this question's from Roberto Cortez, and he asks,
I know this guy.
Antonio, how do you feel wearing baby blue?
Roberto, you saw me dressed in white. You saw me dressed in blue tonight. And I can assure you that's the last time ever. No more colors.
So maybe next year we'll change the DJ 24 show just to Antonio, as always, it's been a blast. Thank you very, very much. I know it's late over there for you, so I appreciate all the time that you've spent with us. Thanks very much.
Thank you, guys. You've done an amazing job. I'm really impressed. Good on you guys. Big clap for the entire team.
Thank you very, very much.
And thanks for having me, guys. Bye.
It's our pleasure. Thank you. Okay, so the next session that we're going to be